Okay, so we will start to do problems as practice on chapter 2. So as you know, in chapter 2, we have introduced several types of bonding between atoms and between molecules. So we will do some practice on this now. We will start by the first question. Everything we'll do here will be posted. Okay. So first, this is a document with all questions involved. I will post it for you as a homework. For you to do it on your own. Okay. And then after doing the sessions together and correcting the questions, I will post the solution. So these problems will be done in 2 sessions, in this session and in the next one on Wednesday to finish them. So now, today I will post it on Blackboard. In this way, please try to complete the questions. We will not have enough time to finish today. And then you can know if you understood well all of these types of bonding between atoms and molecules. And on Wednesday, after finishing the session, I will post for you the solution on Blackboard. Okay? So to start with, in problem 1, what type of bonding is involved in molecules of CH3OH and CH2O? Justify by drawing the Lewis electron structure of the molecule. So first, whenever we want to know what is the type of bonding in molecules, we should look at their atomic number of all elements, of all atomic elements in these molecules. So to start with, in CH3OH, we have C, H, and O as atoms. So I don't want you to remember by heart the atomic numbers. No, you have in the exam, you can access the periodic table. Okay, so we go to the periodic table. So the first step for us is to determine what is the atomic number of C, H, and O. If we go to the periodic table, we can see here that atom C. Okay, it's characterized by an atomic number of 6. This means that it has 6 electrons, and you know that electrons will be divided in orbits. So the first orbit can contain 2 electrons, and then the remaining one can go to 8 to have a stable set. Okay, so if I start with C, for atom C, I have 2 orbits, 1 and 2. On the first one, I will have 2 electrons. So this is the first one, this is the second. Now it's full, the first orbit is full. So electrons will start to occupy the second orbit. So the remaining number of electrons will be 6 minus 2. So they will be dispersed on the second orbit, let's say in this way. Okay? So the Lewis presentation consists just on showing the electrons on the outer orbit. So I put the atom C, and I represent by dots, by points, okay, the electrons on last orbit. So 1, 2, 3, and 4. Okay, these are called the valence electrons. So for C, C is able to share 4 of its electrons with other atoms. The next atom involved in this molecule is H. So if I go for H, and as you can see, H has an atomic number of 1. So it has only 1 electron, which will occupy the first orbit. So if I want to draw the structure, this is the atom H. This is the first orbit, and it will just have 1 electron on this orbit. This is called the planetary model. Okay, the planetary model shows the electrons on how they are dispersed on the orbits. So this is, if you want, the planetary representation. While the Lewis presentation, as we said, will just show the electrons on the second orbit. So this is the Lewis presentation. Okay. So for H, if I just want to do the Lewis presentation, it will be like this. I will just put H and with 1 point. So like this. This is the Lewis presentation of H. This is the planetary representation. Okay, so I am done with C and H. H can share 1 electron, C can share 4 electrons, and oxygen O, atom of oxygen, has an atomic number of 8. So also for oxygen, I have 2 electrons on the first orbit, and the remaining number of electrons will be 6. So if I want to represent O, so let me now just go back to the question. I will put the atomic number here. So I will write first, so the first step to determine the type of bonding, in a molecule is to determine the atomic number of the atoms constituting the molecule. Okay, so here in our first question, what is the molecule? In molecule, CH3OH, the atoms are C with an atomic number of 6, H with an atomic number of 1, and O with an atomic number of 8. So the next step is to draw the Lewis electron structure for each atom. Okay. So the next step is to draw the Lewis electron structure for each element. Okay, so we have already done together this for C and H, so we will just repeat this for C and H. Okay, so for C, I just put 4 dots, since the first orbit will include 2, and the remaining electrons will occupy the second orbit. So I have 4 dots. For H, it has just 1 electrons, because the atomic number is 1, so it's 1 electron on its first orbit. and for O. Okay, so for O, if you want, sometimes the planetary structure will help you to know the Lewis structure. Okay, so if you want, or you do it in your head, if I have 8 electrons, 2 on the first, 6 on the second. Okay, and if they ask you for the planetary model, so the planetary model for O, I just do the following drawing. I put O and I draw 2 orbits. This is the first one. This is the second one. So I have 2 electrons on the first, and the remaining number, 8 minus 2 is 6. So I have 6 additional electrons. And in general, they are equally dispersed, okay, on the orbit. Okay, so now I have these 6 electrons. If I want to do the Lewis presentation, so I have O, then I represent first 1, 2, 3, and 4, and then when I complete the 4, I put 2 dots, for example here, and 2 dots here, so which will result in a total number of 6 around. Okay. Yes, of course, these are possible exam questions, of course. So the exam style, Karim, will be divided into 2 types of questions. The first question will test your knowledge about the material. So everything mentioned in the recorded PowerPoint, you are responsible of this information. So just try to understand it. And if you read the slide several times, you will know the information. So you will have multiple choice questions to test the information in the slides, which is recorded over PowerPoint. Okay, and the second type of questions will be applications. So as you can see, for example, chapter 1 is an introduction, but even if it's an introduction, you should know the information in this chapter. Okay, not in for example, we mentioned, let's say that we have rolling and forging as manufacturing process. You just should know this. You should not know them in detail, because in next chapters we will learn, for example, what are the characteristics of rolling, what are the characteristics of forging, etc. But the introduction is very important for you to categorize the different processes and to understand them. And all information mentioned, you are responsible for in the first exam. Okay, yes, of course I will upload correction of the MCQ. Yes, anyway, once we reach once all questions will be covered, because if you try to read the MCQ, the questions are from several chapters. So once we cover the chapters, we will go over this MCQ, and you will see that you will be able to answer them without correction, because all information is in this slide. But anyway, we will do them together, the MCQ, and it will help you to know the style of questions in the exam. Okay. So these are possible questions, because as I told you, the exam is divided into MCQ and problem questions. So one of the problem questions will be on type of bonding between atoms, between molecules, etc. Okay. So we were talking about O. So if you want to draw the planetary model, we can put in detail how the electrons are dispersed around the atom. And for the Lewis structure, we just present the number of valence electrons which are present on the last orbit. Okay, and here they are 6. So we will put 6 dots around O. Now, what is the type of bonding here? It is ionic, or it is covalent type, or it's metallic. So you know we have 3 types: ionic, covalent, and metallic. First, to have metallic bonding, what was the condition? All atoms involved have low number of electrons on their final orbit, which is not the case here. We have C and O here, which has a number higher or equal to 4, and even H here. H here needs just one electron to achieve a stable set of 2. Okay, so the dominant type here will be what? Will be covalent bonding between them.
Covalent bonding.
Because they will tend to share their electrons in order to achieve a stable set of 8 or 2. For hydrogen is 2, for C and O it is 8. So here we say since the atoms involved in molecule CH3OH have all needs a low number. All need a low number of electrons to reach their stable state, which is 2 electrons for H and for C. Okay, C needs 4 electrons, H needs 2. Okay, and 4 for C and 2 for O. Okay, then the type of bonding in the molecule will be covalent bond. Okay, then covalent bonding will take place between the atoms. Okay, now if you want to try to draw the Lewis structure of the molecule, how it will be? So first, let us do some analysis. We have 1 atom of C, okay, 4 atoms of H in total, and 1 oxygen. Okay, so maybe you can think why we one possibility. So this is C here. This is C. It can share 4 electrons. So 1, 2, 3, and 4. So why to not share with 4H like this? So 1 electron shared with first H, with second H, with third one, and with fourth one. Is this right if I do this? If
No,
I put
because it
C
needs
with...
to share with the O.
Very good. And this, if I do this, it will not be able to share with O. So I cannot put the 4 hydrogen atoms sharing electron only with C, because O will not have a place in this molecule, since this molecule is already stable and it will not need any other atom to be in the molecule. This is why I will say no, one of the atoms here will not be H, so C will connect with 3 hydrogen atoms and with 1 oxygen atoms. And now the remaining H will connect with O. Why? Because as you know, O can share 2 electrons. So it will share 1 with C and 1 with H. Okay, so the final structure of the molecule will be like this. So let me draw it again. So this is C. C will share electrons with 3 H atoms. Just one thing, you have here certain angles between the bondings, but you are not responsible of how to know this angle. So I will consider right whatever you do. Okay, just you should show me it's connecting to which atoms. Okay, because in chemistry you will learn in detail what will be the angles between the bondings to reach a stable structure. So this is H, H, and H. And a forced relation of C will be with oxygen, O, and O will in turn share one electron with H. So in total, O will share one electron with C, one electron with H. And in this way, of course, we should still present. So as you can see here, C will share all his electrons, and H also. However, O will share only 2 electrons, and we should present the other electrons on its outer orbit. So he has 4 electrons that are not shared. 4 not shared and 2 shared. So now we can verify that it's a stable structure, since each atom will have a stable set of electrons on its outer orbit. So for example, for H, what is the stable number of electrons? It's 2. So as you can see here, each H atom is having 2 electrons on its outer orbit because it's sharing with others. C atom has for each line represents 2 electrons that are shared between the 2 atoms. So for C, around C we have 2 plus 2 4 plus 2 6 plus 2 8. So also C is stable. It's surrounded by 8 electrons. Now for oxygen, it's the same. Oxygen already has 4 electrons for him only, and he is sharing 2 with others. So 1 2 3 4. You have here it's a 2 shared electrons, so you can add 4 plus 2 6 and plus 2 8. So H, C, and O atoms have reached their stable configuration. So this is my molecule.
Doctor?
One minute just. One is asking, yes, how H needs 2 electrons. Look, the atomic number of H is 1, okay? So H has 1 electron on its outer orbit, okay? But we know that the first orbit will be in general, to have a stable configuration, we should have 2 electrons on the first orbit. So since H has only 1, it will try to share electrons with others in order to have 2 electrons on its outer orbit, okay? So from the planetary model, the first orbit can have a maximum 2. So if it is 2, it is a stable configuration for the first orbit. Since H has only 1, it will try to share with some other atoms in order to have 2 electrons on its first orbit, okay? Now, for example, if I take for C, it has 6 electrons. 2 will be on the first orbit, and 4 will be on the second orbit. But the second orbit will have the most stable configuration if it has 8 electrons. This is why C will tend to share with other atoms electrons in order to reach the stable set of 8. Okay, so since it has 4 only, it will try to share other 4 electrons to reach the stable set. Okay. Yes. Is someone asking a question?
Doctor, I have a question.
Yes.
Okay. Here we knew that the bond is covalent by drawing the Lewis structure.
Yes.
Can we know if it's metallic by the same way? What's the
Yes.
indication?
Yes. For look,
metallic.
The condition for metallic bonding, okay, is that all atoms have few number of electrons on their outer orbit. Because if all have low number of electrons, so what they will do, they will all share together their electrons which will form a cloud of electrons that is common between all, which is called metallic bonding. Okay, so the criteria for metallic bonding, I will write it here.
And there aren't enough electrons to be shared to be able
Yes,
to...
there are not enough electrons to be shared to give a covalent bonding. Okay, so what they will do, they will just form an outer shell for all atoms inside, as is represented in the course material. So if you go back to the course material here, okay, you can see that where we have the slide of ionic metallic bonding, it's just here. So look, if you have several atoms that all are in the metal zone, so all have few number of electrons on their outer orbit, the number of electrons will be not enough, okay, to form a stable set for all. So what will be done? We will have the electrons will be dispersed as a cloud shared between all atoms. Okay, so this is metallic bonding. To know that we have a metallic bonding, all atoms constituting the molecule should have low number of electrons on their outer shell, so they are far from reaching the stable set. Okay, so it should be the number of electrons will be higher. If I'm talking about a second orbit, it should be lower than 4, yani 3 or 2 or 1. Okay, so all atoms should have 1 or 2 or 3 electrons at their outer orbit in order to say that they will form a metallic bonding structure. Okay.
Okay, thank you, doctor.
Except of hydrogen. Hydrogen is the only exception because it has only 1 electron. So 1 electron, if it's got just 1 electron, it will be stable. Yes.
هون H needed 1 more electron to become stable, مظبوط.
مظبوط. Exactly. H needs 1
okay,
electron.
Can you get back to the slide of the exercise?
Sorry, can you repeat? I didn't hear you well.
Can you get back to the slide of the exercise,
yes,
please?
Yes, of course. Yes, tell me.
Okay, in the parentheses, should it be 1 electron for hydrogen? بس لتحت شوي, a little bit down. Yes, here.
Yeah. The atomic number of H is 1, okay? Because it has 1 electron. But when it will share with others another electron, it will have 2, okay? So the atomic number represents the number of electrons before
shared. Okay, so we're talking here about the shared electron?
Yes. When you share electrons, H will have 2 electrons on its outer orbit. Okay? Because look, when you have like this is C, so you can see it in more detail. You can see it here in the slide, in the figure. When you have the definition of covalent bonding, as you can see here, the electrons shared will be common to both. So you can consider that if this is H, for example, H will now have 2 electrons on its orbit, on its outer orbit, because it has already 1 and it's sharing 1, okay, with the other. So you will have 2 electrons in common between the 2 atoms. Okay?
Yes.
So after doing a covalent bonding, it will have, H will have 2 electrons on its outer orbit. Okay?
Doctor, but you wrote
okay.
but
just 1 second, please. Yes.
يعني consider if you have an element having 5 valence electron. In this case, it will share 3.
Yes, exactly.
Okay, thank you.
Yes, who was asking a question?
Yes, doctor, in the parentheses, you wrote the electrons missing. So you wrote 4 for carbon and 2 for oxygen, but you wrote 2 for hydrogen. So I think
No,
it should
one
be
for
one, right?
no. I mean here, I should clarify this. 2 electrons for hydrogen to reach a stable set. Okay, I was talking about reaching a stable set. So you need 2 electrons for H to reach a stable set, 8 for C, okay, and 8 for O. The missing electron, now I will clarify it here. So the missing electron, so the missing electrons, okay, for H is 1, okay, because it needs to reach 2. So for H is 1, since the stable set for C is 8 and it has 4, so how much is missing for C? 4 are missing for C, okay, and 2 are missing for O, okay, and 2 missing for O, okay. Because the stable set for H, why it's just 2? Since H has only 1 orbit, okay? So since the stable set for the first orbit is 2 electrons and H has only 1, so the missing electrons number for H will be 1, okay? While the stable set for C will be 8 because the number of the final orbit for C is 2, okay? And the second orbit to be on the stable state should reach 8. So since C has 4 electrons on its outer orbit, it will still need 4 other electrons to reach the equilibrium state, okay? And for O, since also it has 2 orbits, okay, and he has 6 electrons on the second orbit, and the stable state is 8 for O, okay, then it will still need 2. And I should talk about stable set and missing electrons separately to not confuse, okay? Any other question before I continue? Okay, so now the second step is to draw the molecule, the bonding type for molecule CH2O, okay? So for CH2O, what do we have? So we have, we have C, H, and O also. But as you can see, this molecule is much more easier. You know why? Because it's more straightforward than the first one. Since if you just try to, first, since as we said before, the involved atoms are C, H, and O, which require low number to reach their stable set. So the type of bonding will be covalent type, okay? So now, if I try to draw the molecule, so this is C, and I know that C can share 4 electrons, okay? So to start with, since I have 2 hydrogen, so it will, it will share the first electron with the first hydrogen atom, the second electron with the second hydrogen atom, and now for oxygen, since C still have 2 electrons to share, okay, and oxygen needs 2 electrons to share, so it's fine. All I still have to put is oxygen. So C will also share the remaining 2 electrons with oxygen, and this will be my final molecule. So this is O. So here it's much easier than the first molecule. This is O, and since O still have 4 electrons that are not shared, so I should represent them. Okay, so I can put them here. So 1, 2, and 3, 4. Okay. So in total, I can see that each atom in this way will have a stable set of electrons, because each hydrogen atom will have 2 electrons, which is a stable set since H has only 1 orbit. For C, it will have 1, 2, 3, 4, 5, 6, 7, 8. Since it's 4 lines, it means that you have sharing of 2 electrons on each line. So it will result, since you have 4 lines, it will result in 8 electrons on the outer orbit of C, while O will share 2 electrons and the 4 other are just electrons for O. Okay.
Doctor, is this a
Karim,
covalent
it's
bond
fine
or
with the
what?
double bond. Yes, who was asking a question? Can you repeat, please?
Yeah, of course. I was asking if it was a covalent bond.
Yes, of course it's a covalent bond because all electrons are shared here. Okay? This is
Okay,
a
but
double
no.
covalent bond because O will share 2 electrons with C. So you will have an electron here, electron given from O and one given from C. Okay? And also you will have this is called a double covalent bond since 2 electrons of O are shared with 2 electrons of C. So you can consider here that these 4 electrons are common between C and O. So when you want to count the number now, the number of electrons of C, you will have 8 because you have 1, 2, 3, 4, and here 5 and 6. Okay? And the same for the second here, 5 and 6. Okay? And when you want to count for H, you count 1, 2, and here 1, 2. Okay? So in this way, all your atoms will have on their outer orbit. For H, it will have 2 electrons on its outer orbit. For C, it will have 8, and also for oxygen, it will have 8. Okay? Any other questions?
Okay, but how? Yes, how are we knowing that it's covalent or ionic or metallic? I know that you said that for a covalent bond, we need the atoms to have a low number of electrons. But what is considered
for metallic bonding, it should have low number of atoms. For ionic bonding, the condition is that one atom should have low number of electrons on its outer orbit, and the other atom should have a high number of electrons on its outer orbit. So what will happen? The atom with low electron on his outer orbit will lose these electrons, so that these electrons will be gained by the other atom, and this will form ions with opposed charges that will attract each other. We will do practice on this in the other problems on ionic bond. Okay.
Okay, but what is considered a low number? Because in the first example, we had O with 6 electrons, so 6 out of 8 is considered a low number, or
no? It's
like
a high number, of course. Of course, it's a high number. Look, the only critical atom is H, because H can do ionic bonding and it can do covalent bonding. Why? Because H can lose 1 electron to give you H+, the ion H+, and can share 1 electron to reach a stable set of 2. So H can play both roles, can do an ionic bonding and can do a covalent bonding. To know, you should look at the other atoms. Here, your other atoms, both C and H, have, to consider it's a high number enough, it should be higher than 3. So 4, 5, 6, and 7. Okay, because 8 is already stable, so it does not need to do any other bonding. Okay, so if you have a number of 4, 5, 6, or 7, you can consider that this atom is more exposed to do covalent bonding. Okay, while if you have 1, 2, or 3, then it will do metallic bonding if all others have only 1, 2, 3, or it can do ionic bonding if it's, for example, you have 1